All right, topic 6. What are we going to look at? We are going to look at the periodic table. If we look at the periodic table and we use part of our topic 5 knowledge in terms of valence electrons, gaining or losing, we can break this table down into 3 major element types. 3 major element types. So let's do that. Let's take this table and let's reveal the 3 element types. So the first thing in topic 6, let's go with element types. Type number 1, which does come back from your topic 5 where we had elements with low level of valence and they would lose electrons and have a positive oxidation number, we can lump those into an element type that are called metals. And you've heard of it before. Well, there's just more things you know about these guys. Elements that are classified as metals, low valence, which comes from your topic 5. What do I mean by low? Probably a 1 to 3 range. You also know from topic 5 that with a low valence like that, you simply lose those electrons. So lose electrons. And you also know from topic 5 that if an element or atom loses electrons, it has a positive oxidation number. So all elements that are classified as metals have these things in common, which means they all have very similar properties. They're shiny, they're malleable, they conduct electricity. They would love to combine with elements on the far right of the table. They have similar properties. Probably the most important thing for you guys, where in the heck are these metals on that table? And my friends, I bet you have sat in class, in a science class, and have looked at that table on the wall and have wondered, I wonder what that little zigzag line is. This zigzag line. Yeah, you've seen it. There's a reason why it's there. It helps you determine element types based on position. Metals, easy. Oh my gosh, they're all to the left. So look at this table, man. If you block off this, look at all the metals that we have. Like 90% of the elements could be classified as metals. Why? Low valence, lose electrons, positive oxidation number. Huge chunk of the table are metals. Malleable, conduct electricity, shiny. Okay. Type 2. And yeah, I bet I've heard of type 2. Well, it's simply the opposite of metals, which are nonmetals. And they are exactly the opposite of what we have right here. So let's keep it in the same order, keep the notes nice and clean. So let's go right here. No, not nonmetals, they have a high valence. What classifies as high? Well, from your topic 5, it's the ones that range from 5 to 7. No, they don't do this. It's the opposite. So they gain electrons. Why do they gain? Shoot, man, they're so close to that octet. They're only a few electrons short. No, it's going to be the opposite. These guys will pull off and produce a negative oxidation number. Which again, my friends, you're going to find out in topics 7 through 15 that this is what we use when we start to combine elements, which is right around the corner. It's next week. Okay. Location, location, location. You probably heard that in real estate. Or you haven't because you don't own a house. Location for nonmetals, yes, you're right. It's to the right. Now, look, my favorite second period on what's today? Thursday. Look, dude, we only have a couple. We only have a couple to worry about. Now, if you've noticed, what I haven't touched on yet are the guys that are around this little zigzag line. Yes, we have element types that are around this little zigzag line. They're not called metals. They're not called nonmetals. I don't know if you have heard of these or not. They're actually called metalloids. They're really weird. Yes, I wish we were in person learning chemistry, because what I usually do in person with my students, I pass around samples of metals, nonmetals, and metalloids that you guys can hold in your hand. You can feel them. I have you hit them with a hammer. I have you apply electricity to them. I have you guys put them in acid. You know, we do a bunch of tests, and you, man, dude, you can see the difference. But this being a virtual class, it's really difficult to see and experience that. I'm sorry, but that's what we would do. And you would notice right away, if we were in person, these things look wrong. There's just something wrong about them as soon as I plop it in your hand. Come by next year and I'll show you a metalloid, and you'll go, oh, you're right. Okay, these things are a mess. You guys, the valence, I hate to tell you this, and that's why these are frustrating. The valence can range from 3 to 7. So some have a little bit of this going on, and some have a little bit of this going on, and that's why it's really called no man's land. It really is. I don't know, metalloids as a package deal? I don't know. Some gain and some lose. Oxidation number? Well, if it's a gain, I don't know. That's why you have to have the sample in front of you. You have to go test it to find out, okay, this guy's going to do this, this, and this. Location. Ooh, here you go. Okay, now I'm going to be careful when I draw this zigzag line. All right, do I have enough? 1, 2, 3. I need 4. 1, 2. I need one more. Oh no, it's barely going to fit. Oh, it barely fits. Okay, reason why I want it to fit, I want to give you the element symbols that are classified as metalloids. I'm going to grab, I think I'll grab red since it sticks out so much. Okay, my friends, here are your metalloids. I'm simply going to look at the table. I'm going to find that zigzag line, and it's the elements to the left and right of that line, except for one. Here's your first one. Good old boron is classified as a metalloid. Silicon is next. Aluminum is not. That's why if you were in person, I would plop a piece of aluminum in your hand and a piece of silicon, and you would know right away, dude, these things are very different. This thing is weird. Okay, let's see. Germanium is, arsenic is, Sb is, Te is, and I'm at the very edge of my screen, sorry, Po, and squeeze in At. Oh yeah, right. It's just At right here. Some textbooks exclude At. Some throw it in there, and so it's like, okay, so what do I teach? I just throw them all in there. Should be 8. I hope I got 8. 2, 4, 6, yeah, whew. Okay, there they are. There's your 8. So based on topic 5 stuff, big picture, boom, I've got 3 types going on here. And there are the 3 types. I think the most important thing for you is, okay, where are they? And you're going to find out later that this oxidation number is a huge deal that we use. Okay, So there's the element types on the table. I think what we need to do now is look at the detail that this table has. And to look at the detail, sometimes it's better just to take a look at a blank table. This is the one I put in Canvas. Okay, let's look at the things they give you to help you find and determine these elements. Okay, hang on, my cat wants to be outside, hang on. All right, erase, 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 erase. All right, things on the table. Well, we got to take care of groups or families. So here's the second thing in topic number 6. Groups. Some textbooks will use the word families. All right, where are they on the table? Well, the groups have a number 1 through 18. And you're probably thinking, what? I'm talking about these numbers up here. 1 all the way to 18. Now, the table that I placed in Canvas, not the blank one, this one that you need, especially coming up later, man, they're there. It's these numbers right here. They go across and they're 18. Now, obviously, if they're going across from left to right, we're looking at elements in columns. So the next thing I would put under groups and families is the idea that these guys are the columns in your table. Please don't get columns and rows flipped, which happens quite often. Columns, my friends, are up and down, top to bottom. If you are in the same column, if you've got 2 elements, 2 different ones in the same column or same group or family, they have, they have similar properties. Which means they'll behave the same way. So if I had this element here and this one here, and I both put them in acid, probably going to react the same. Do they react the same with copper chloride? Do they have the same property when I put them with another substance? That's what I mean by similar properties. Why do they have similar properties? Back to your topic 5, they have similar valence. They got similar valence. They have similar oxidation numbers. Maybe that's something to put over here. Oxidation numbers. How do I know that? Oh my gosh, you guys, take a look at this table and the pattern. Every single one of these has a +1 oxidation number. All these guys have a +2 oxidation number. Don't get mad at me, I just work here. 3 through 12, they all have a +2 oxidation number. +3. Uh-oh, here comes those 4s that we skip. These guys have a -3, -2, -1, and they don't have an oxidation number because they have an octet. That's what that means. These groups or families, some of them have very, very special names. And that's what I want to look at next. Yes, we have some special columns or groups. Special groups. And let's start on the left and work our way to the right. First one of the special groups is group number 1. And I'm talking about these guys right here, my friends. These. Because it's group 1. They have a special name, and that special name is alkali. if I can get this to fit, alkali metals. Yes, they're metals because they're on the left. Alkali metals. Does that sound familiar, like an alkali battery? The new lithium batteries that we are now producing and using on it, like all my laptop stuff that I have, computer stuff, are alkali batteries. They consist of atoms that are from this first group. Next group is the group right next to it, group 2. They are called alkaline. I know, it's really close. It's like, God, can you please use a completely different word? Sorry, man. Alkali, alkaline. Yes, they are metals. Okay, where are they? They're right here. I guess I probably should have put that in a different color for you. Here, I'll just put a red star. I'll switch colors for you to make it a little bit easier. So there's your alkaline. That, my friends, are the old batteries, the AA, AAAs. Get an alkaline battery. You've probably seen the name on the package of batteries, alkaline. Well, the alkali batteries, the lithium batteries, last longer, produce more energy, that kind of thing. Third section, or third major group, and this one's a big one. I'll even put in a different color for you. Can you even see that's blue? Maybe you can't. That's blue. All right, here, oh my gosh, look at this. Groups, hang on, 3 through 12. 3 through 12. It's this whole part of the table. That whole middle section, they lumped together. They gave it a special name, transitional metals. Kind of a weird name, but if you think about this big picture wise, yeah, it kind of makes sense on why they named it transitional. Transitional means change. You're going to transition to lunch after this, or transition to period 3. I don't know what your schedule is. So, same with these guys. Look, hey, if we start to move over to the right side of the table, we are slowly getting closer to metalloids, and then we'll slowly get into nonmetals. So they are transitioning from one element type to another. That's why they stuck that word in there. Yes, they're metals because they're left of that zigzag line. Okay, I'm trying to switch colors. I'm sorry I didn't do it for the second group, but I will for this group. I hope you can see that's green. Yeah, you can. All right. We have another special group, and it is group 17. And on your table, there, it's these guys. Group 17 has a special name, and the name that they applied to them are halogens. Now, you might not know this, but old light bulbs, the incandescent light bulbs, now we have LEDs, but the old light bulbs, you can get these super bright exterior light bulbs called halogen bulbs. Just ask your mom or dad, guardian, you know what a halogen bulb is? They'll say, yeah, they've heard of them before, because that's what the light bulbs used to be. They used to use these elements in those light bulbs. And then the last group, shoot, I don't know what color to use. I'm sorry, I'm going to have to grab orange, I think. Can you see that's orange? Yeah, maybe you can. Hey, we cannot forget about your favorite group, which is group 18, which is, my friends, these guys right here. Group 18 at the top. Special group, especially from topic number 5. You guys should know that they are called noble gases. They have that lovely stable octet. Okay, so there's the big five. Now, if you noticed, they avoided this area of the table, and they have to, because within a single group, you might have a non-metal, then a metalloid, and then a metalloid, and then a metal, and then a metal. So within group 14, you have all three element types. So it's kind of hard to put a name to something that contains three different element types. Why? Because they have three different set of properties, that's why. Hey, all we have left now is working this way in the table, is working left to right. Let me get rid of this. Well, before I do that, I better ask for questions. I'm kind of going a little fast. All right, then the last part we got to look at are the rows. Rows, sorry, my friends, they're not called rows. That's too simple. So, your third thing in topic 6. No, they're not called rows. They're called periods. Periods. Yes, but I know what you're going to call them. You're going to call them rows. And I'll stick with your language. Just don't you forget, we're going this way, left to right. How many rows do we have in our modern table? Hurry, look. And you're wrong. There's only 7. 1 through 7. I know, I pulled a little trick on you. Just relax. How did I get 7? Well, let's see. I'm going to grab another blank one. Here's the periods. 1, 2, 3, 4, 5, 6, 7. And you're smart. You probably thought 8 and 9. Yeah, well, I would agree with you. But there's a break in this table. And the break is right here. And I bet you have sat in a science class and you have stared at this table and you've always wondered, why? Why did they do this? What's going on with this bottom piece? Well, this bottom piece, I hate to tell you, actually fits right here. Because if you look at these numbers, 55, 56, 72, yeah, well, the big chunk has been removed and is actually down here. And then if you look right here, you go 87, 88, 104? Well, that's because they took a big chunk and put it down here in this row or period. And your number one question you probably had over the years is, why? I'm going to show you. I'm going to show you the why. And the why goes back to your topic 5. Okay, watch this. My friends, this part of the table, right here, this part of your table is actually filling and using the S sublevel. This middle part of your table is actually using a different sublevel. And this is where I said if you have highlighters and if you want to print the table from Canvas, you can. If you don't want to, you don't have to. I'm just showing you the big 4 parts of your table. This, my friend, is the D's. This part of your table sublevel wise, except helium. Maybe I should not. I probably should have done this. Helium is an oddball. This part of the table, except helium, is actually filling and using the P sublevel. And you probably know what's going on in the bottom. This part of the table is using your fourth sublevel from, Jesus, how did I miss the line? God, I went way off the line. Did you see that? That was horrible. Yeah, what's the rule? Color within the lines? Well, I probably didn't do well in elementary school. That, my friends, is the F sublevel. That's why the break occurs, and they have gone from here down to here, because these guys fill up the F sublevels. And once the F is full, according to your lovely flow chart, poof, you go back into the D's. And once the D's are full, you hit the P's. What am I talking about? I'm talking about this. I'm talking about this. Because look. We're right there. You see this? After I use a 6S2, hey, I would loop back around and look what shows up in F. 6S2 then goes to the F's, and then look. What happens when the F's are completely full with 14? Boom, it goes back into the D's. So it goes here and loops and goes back, and now it fills up the D's. What comes after a D? Well, there better be a freaking P on my chart. And sure enough, it is. That probably gave a lot of you goosebumps on how this whole thing works. Well, you're welcome. So, what's left with periods? What's left with periods? What's left with periods? Here's what's left with periods. If you get the big picture of this and the four sublevels, same highest, I gotta make this fit, main level. I don't know where to go. I know where I want to go. Same highest main level. Well, I guess that works. Maybe that works. Maybe it does for me because I know what I'm doing. So if I'm right here, if I am in this period, I know that every single one of these elements, these atoms, are filling the fifth main level. If I'm here in period 3, I know that all of these guys are filling the third main level. And that's why you only have 7 on the table. Because if you think back to lovely topic 5, and I was drawing these stupid things, and you got bored, and you lost track, I said, hey, main level 1, 2, 3, all the way out to 7. That's where they get the 7. And that's why it stops at 7. Okay. What else? I don't think there's anything else. What I would like you to be able to do now is, if I was to give you an element, could you tell me the period it's in, the group it's in, element type, and if it has a special name? Yeah? Okay, like this. So let me get rid of this so I've got more room to work. Let me get rid of this. What I mean is, can you do this? If I was to give you, and I'll have to use this table because you need to know where I am. Oh, sorry. If I was to use this guy, MO, number 42. Could you use your table and your topic 6 knowledge and simply tell me what group number he is in? Can you tell me the period number that he is in? Can you tell me if it has a special group name, like alkali, alkaline, transitional? And then the fourth and final piece, could you tell me if it is a metal, a non, or a metalloid? And I'll do this first one for you. If you just want to sit back and watch, that's totally fine. I'll do it because I like doing this kind of stuff. Okay, so here's how I would do this. I see that he's right here, so I'm going to fold this table. I'm going to fold it because otherwise it's too big. All right, so he's right here. All right, watch what I'm going to do. Group number, I am simply going to scoot all the way to the top and grab that 6. Period number, okay, here he is. I'm going to scoot over to the left, and there's your period numbers. Maybe I should have done that to this lovely table. That is my fault. Periods are these numbers here, the 1 through 7. That's your periods. Yeah, sorry about that. Group name. Okay, is there a special name attached to elements that are in this middle part of the table? Yes. The special group name for this, especially this group, transitional metals. And then finally, dude, what kind of element is this? Is this guy a metal, non-metal, or a metalloid? There's the key. Table, zigzag line, left side. I know it. I know what that sucker is. If I can fold this table, he would be a metal. That's what I want from you in topic 6. So I think it's in my best interest and yours if I was to give you 2. Can I give you 2? Let me give you 2, and let's see if you can do 1 through 4 with these 2. Which means I'm going to go back and erase what I have in blue. And I am simply going to go, I better get rid of this. Okay, I'm going to get rid of the element symbol and his Z number. I'm going to get rid of that. I'm going to put a new one in there. I want you right now answer these 4 questions. Okay, let me grab, I'm going to grab calcium. Come on, hurry. I'll even give you his Z number, which is 20. Number 2, I'm going to grab iodine, and he is number 53. But you guys, I have the same questions. Same questions, just the same 4 questions, but now with a second element. Okay, I'll stop talking. Go ahead, complete that. Okay, you keep going. I'm going to do calcium. If you're still on iodine, keep going. And I will give you my answers for good old calcium. Calcium, that sucker is in group 2. He's in period number 4. Ooh, special name. Alkaline. And he is a metal. Boom. Quick. Easy. So once again, man, just find him, the element, scoot up. That'll give you their group number. Here's all the group numbers at the top. I know, I know, I see it too. There's Roman numerals. That's because I hate to tell you this, there's 3 different ways in which they labeled groups, and it's confusing. So we're going to use the simplest system, which is the 1 through 18 system. You don't want me throwing Roman numerals in your face. That's a later topic. Period, again, just locate the element and simply scoot to the left, and here's all your period numbers. My friends, there's only 7 total. If you get 8 or 9, I don't know what table you have, but it's not mine. And he is in this little special column or family called alkaline metals. And he is to the left of this zigzag line, and therefore he is a metal. Iodine. Pooh, there he is. There he is. All right, so group. I just go right to the top, 17. Kind of a pain in the butt, but you got to find him and go shoot him all the way across. There's his period number, period 5. So I know that all of those guys in that row are filling the 5th main level with electrons. Oh, special name. Yes. Group 17 has a special name of halogen. What's left? Oh yeah, it is to the right of the zigzag line, and he's not one of the special ones I identified. He is a non-metal.